Now, when sinus rhythms were discussed, you realize that once you've learned the rules of a sinus rhythm, that did not just give you the name of a single rhythm, but it gave you the name of a number of different rhythms, and they were all based on the rate. So if the rate was 60 to 100 and it fit all the characteristics of a sinus rhythm, so let me draw you an example of a sinus rhythm here, just to kind of get the process started. So if I come over here, and again, bear with the kind of sloppiness here, and the slowness. Alright, not the greatest example, but it'll work. If you notice on here, the QRSs are narrow. I have P waves that are present here. They are upright. Are they round? Well, this one in particular here looks a little bit pointy, but they're relatively consistent in terms of their height and their width, and more so than not with their shape. Yes, if you start seeing variations like this in the way the P waves look, that can be indications of different things, but essentially they're all upright, they're all round for the most part, and they're relatively symmetric. Now, the PR ratio on here, it's 1 to 1. Every time I have a P wave, I have a QRS paired with it. Every time I have a QRS, I had a P wave paired with it. The R to R, or I'm sorry, PR interval on here is consistent. So the distance between each of the P waves and the QRSs, possibly with the exception of this one where I got a little sloppy on the QRS, maybe a little bit at the end, but the QRS PR interval here is relatively the same on each and every one of these. And the R to R finally here is regular. That's fairly consistent throughout. Now, if I told you that this was a 6-second strip, that would be a rate of 1, 2, 3, 4, 5, 6, 7 beats in a 6-second strip. So you multiply by 10, you have a rate of about 70. Again, it could be anywhere pretty much from 61 all the way up to 79, but we've met all the characteristics here of a sinus rhythm and the rates between 60 and 100, so that would be normal sinus. Then if you had a rate that was less than 60, it would be sinus bradycardia. If it was 100 to 150, it's sinus tachycardia, and if it gets up over 150, it's SVT, or more specifically, if it fits all these criteria and you really do have the upright P waves on each one, consistent, regular R to R, and so forth, that's atrial tachycardia. So we've met all these characteristics. Now what's nice here is as we go through a couple of these other categories here, you've got the junctional rhythms and the ventricular rhythms that we're going to discuss this week. The junctional rhythms, once you learn the rules for a junctional rhythm, it applies to several different rhythms that are based on rate. So if I take a look at a different rhythm, now let me draw you an example that looks like this. Now, on this one, I got a little sloppy on this one. It's a little bit wider than the others, but again, like I said, you have to humor me slightly because it's the blackboard issues here. But on this one, just humor me and say that this one is 3 blocks wide and the other ones are about 2 to 2.5 blocks wide. So I have narrow QRSs. However, do I have any P waves? No, I don't have any P waves at all. Well, that can be a bit of a problem here. So what would that indicate? The QRSs indicate the ventricular depolarization. My ventricles are depolarizing. I have QRSs. And more so, my ventricles are depolarizing quickly. Even this one made it within the cut. Again, like I said, you have to humor me, but we'll say that's just exactly 3 blocks wide. So they all made it within the cut. So my ventricles are depolarizing normally, but the P waves, what do the P waves represent? Well, P waves represent atrial depolarization. And in this case, my atria are not depolarizing at all. So with no atrial depolarization, then I know this heartbeat didn't start at the sinus node because it doesn't have an atrial beat that occurs after that, or an atrial depolarization. It didn't occur in the atria because the atria are essentially doing nothing. As a result of this, I have no P waves at all. So the answer to that question would be no, there are no P waves. There's no PR ratio, or in a sense, the PR ratio would be that I have more QRSs. I have 5 QRSs on here, and I have no P waves. Now, I'm not interested in a 5 to 0 ratio or a 2 to 3 ratio or something that so much as I am, do I have an equal match? Is it a 1 to 1 ratio? Do I have the same number of P waves as I have QRSs? If that's not true, do I have more P waves or do I have more QRSs? Well, in this case, I have more QRSs than I have P waves. The PR interval is unable to obtain. That's a fancy term that we can use in medicine here. And it's just kind of a fancy way of, if you watch the Jetsons back in the day, they had Astor on there. So it's, I don't know, it's a fancy way of saying that. If you walk into a doc and you say, hey, doc, I've got this crazy looking rash. Can you tell me what that is? I don't know. Well, you don't really feel comfortable about that. But if the doc were to say, it appears that you have an urticaria of idiopathic origin, essentially what they're saying is, I don't know. But what they mean is you got a rash, and I have no idea what caused it, but it sounds really cool and fancy. So we use some of these fancy terms when we're describing our rhythms, and unable to obtain, or UTO, we can abbreviate unable to obtain as UTO. That works as an answer. I'm going to give you a hint. When you take these tests, if you don't know the answer, write down UTO. That's not going to be right for every single answer, but at least you have a chance that it might possibly be right, or it might be a situation where you really can't obtain. In this case, we can't obtain a PR interval because there's no P wave to get an interval off of. So UTO would be a correct answer here. And just as a safety, put that down on anything that you're not sure. Now, I don't want you to go into the test and just write UTO 7 times for each rhythm that you get, because that's going to end up failing. You're not going to do well. But if you look at these rhythms and you come up with something where you really can't obtain, then put UTO down, and we can get that piece. Now, if you look at the R to R, I did a fairly decent job on here. These are basically equally spaced. So my R to R is regular on here. And finally, the rate, I know it's a little smaller than the one above, but we're going to say that this is a 6-second strip as well. And I've got 1, 2, 3, 4, 5 beats times 10. I've got a rate of about 50 beats per minute. Now, there's a couple of things that we need to do when we're judging, is this a atrial or a sinus or a junctional or a ventricular rhythm. And in this case, I don't have any P waves, so I know this isn't a sinus rhythm because the sinus rhythms have upright P waves. And I know it's not an atrial rhythm because the atrial rhythms, I've got atrial tach, which is a really fast sinus rhythm. I've got atrial flutter, which is where you have the constant flutter that's occurring. And you've got atrial fibrillation, where there's a ton of random atrial activity. I don't see any activity on here. The P waves are essentially absent. There's no activity here whatsoever, so there's no P waves. However, I would say then, well, if it's not up in the sinus or in the atria, then it must be down in the ventricles. The problem that we have here is we have narrow QRSs. And a narrow QRS, the only way physiologically that you can get the right and the left ventricles to fire at roughly the same time, I do examples of this in class. I have the class clap, and I have them watch me, and I start the clap so they can see me when I'm swinging my hands together and I actually clap. I tell them to clap with me, and we get this clap, 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 and we get going in a nice steady rhythm. And I can actually slow the rhythm down a bit, I can speed the rhythm up, but they can see when I'm clapping, and they follow along with that. Now, to do the example, what I do is I tell them, close your eyes. When you hear a clap, then I want you to clap. And I'll go ahead and clap, and then I'll clap with a little bit of a random rhythm, or I'll wait, and they might keep going, But then I'll throw a clap somewhere in the middle, so it all of a sudden starts turning clap, 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 and it's all just random claps. So there's really no regulation and no control. And just to make the long story short on here, essentially you can't get your ventricles, right and left side, to fire together unless that signal came from at or above the AV junction. It has to travel down the right and left bundle branches through the Purkinje fibers and get those two to fire at the same time. If they both depolarize at the same time, you'll end up with a narrow QRS. So one of the things when we talk about ventricular rhythm shortly here is I'm going to tell you if you see a wide QRS, the first type of rhythm you should be considering is that this is a ventricular rhythm. But in this particular case, I have a narrow QRS, so the narrow QRSs is a hard and fast rule. It's impossible physiologically to have a narrow QRS if the rhythm originated in the ventricles. I know it didn't start at the sinus node because there's no P wave. I know it didn't start in the atria because there's no AFib or aflutter activity here. There's really no atrial activity at all. But it didn't start down in the ventricles, so the only thing that we're left is in the middle. We're left with the AV junction. So this is classified as a junctional rhythm. So this would be, just plain and simple, a junctional rhythm. And I'm going to leave a space here rather intentionally. Some people, when they name this, like to be a little bit fancier, so they'll call this an escape. So they'll call it a junctional escape rhythm because people are essentially escaping death. It's basically the junction is taking over and running the show at this point. Well, now that we know that the rhythm started in the junction, we have to determine what is the name of the rhythm, or is this the right rate for the junction? So now the AV junction, what's the normal firing rate for the AV junction? I'm going to write kind of small on here, so bear with me if you're on a small screen. I'll put it over here on the side. But the normal firing rate for the AV junction is going to be 40 to 60 beats per minute. And just to save space, I'm going to connect that over here. So if I have a rate of 40 to 60 and there's no P waves, but I have the narrow QRS, that's a junctional escape rhythm. Now, if the rate is less than 40, then the name for that is going to be, it's too slow for the junction. So that's called junctional bradycardia. And I'll abbreviate that for now just to save some space. But junctional bradycardia here is if the rate's less than 40. Now I'm going to skip a little space up here, so bear with me on this. If the rate is between 100 and 150, that's going to be junctional, and I'm running out of space here too, so I'm going to abbreviate. That's junctional tachycardia. So the rate had to be over 100, so a rate of 100 to 150 is junctional tachycardia. And once I get up to about 151 or higher, if you remember under atrial rhythms, we talked a little bit about supraventricular tachycardia. Supraventricular tachycardia is SVT, and SVT is a narrow QRS with a rate over 150. Well, in this case, we've got a narrow QRS, and if the rate's over 150, well, that's SVT. But the specific type of SVT that we're dealing with is junctional tachycardia. So I'll put that in parentheses here. It's SVT, it's junctional tachycardia. So if my rate is 40 to 60, that's what I expect the junction to fire. If you remember, the sinus node fires 60 to 100. If the junction has to pick up the slack, it's a rate between 40 and 60. If it's slow for the junction, it's junctional bradycardia. If it's over 100, then it's junctional tachycardia, and if it gets up over 150, not only is it junctional tach, but it qualifies as SVT. And in just a few weeks here, we're going to be talking about management, and essentially this SVT is where we start managing people. Slightly fast junctional rhythm, we don't really do anything in an emergent setting to take care of that. But once we get somebody that gets a heart rate that's up over 150, that's not really conducive for the heart to go for a long time. Now, if you notice, we've got a gap in here. So this gap goes from 61 to 99, and you can argue back and forth. Is 60 really part of this rhythm, or is it part of the junctional escape rhythm? I try to keep the names essentially as normal as possible, so the junctional escape rhythm here, a rate of 60, I'd qualify that as junctional escape rhythm. But 61 to 99, tachycardia begins at 100. So we're not up to tachycardia yet. However, it's faster than what I expect the junction to go. So they have a fancy name for this one, and if you think what's that tall, slender pedal that you step down on the car to make it go, it's called an accelerator. So the name for this rhythm is called, and I'm going to abbreviate, accelerated junctional rhythm. And you can certainly call it accelerated junctional escape rhythm, but accelerated junctional rhythm, and I'm going to really abbreviate because we're out of space, but accelerated junctional rhythm if it's between 61 and 99. Well, why would that matter? The primary thing, again, as we talk about management, we'll discuss this in greater depth, but I want to know, is the problem with the junction trying to fire too fast, or is the problem that the sinus node isn't doing anything? Well, if I've got a heart rate of 50, my sinus node's supposed to be firing a rate of 60 to 100. That's the norm for an adult. So if the problem is that the heart rate is 40 to 60, then what we're saying is that the junction is keeping us from dying. It's allowing the ventricles to keep pumping blood to the brain and the rest of the body, which makes the body a lot happier. So the junctional escape rhythm there, that 40 to 60. If on the other hand the rate's 80, for example, well, the sinus node may say, I want to fire at a rate of 60. And if the junction is firing at a rate of 80, the sinus node may not actually have the opportunity to take over and make a rhythm. So it's important to understand that the accelerated junctional rhythm is primarily from an understanding process. Is the problem that the junction is moving too fast, or is the problem that the sinus node is not moving fast enough? Junctional escape rhythm, the sinus node is not moving fast enough. Accelerated junctional, it's possible that the sinus node just isn't doing its job, but we don't really know because the sinus node could be wanting just to keep the rate right at 60 and make it nice and comfortable, but the junction is going too fast. So that is one classification, one type of junctional rhythm, but not only did we come up with the fact that it's a junctional rhythm, we can classify it and name it this way. Now, bear with me because we're not quite done with this junctional rhythms yet. So I'm going to come back over here and we're going to close that rhythm, and I'm going to get a fresh sheet here to work off of. Now, if I give you a rhythm that's like this, bear with me just a second here. Got to change things around a bit. Okay, so if I get a rhythm that looks like this, now I apologize because it's a little bit irregular. That's not intentional, but what I want you to gather out of here is QRSs are still narrow. They're pretty much straight up and down. And I do have P waves here, but if you look, the P waves are kind of embedded into the QRS, or I guess the QRS is embedded in the P waves. And I'm going to tell you here, since it's my example and I get to set the rules, that the PR interval here is about a block and a half. So it's a very short PR interval. If you remember, the PR interval is supposed to be 3 to 5 blocks. So if it's less than 3 blocks, that means that there wasn't enough time for this signal to come all the way from the sinus node. Now, I can give you an example here. My wife and I met on the internet when we were dating, and she lived in Columbus, and I lived in Dayton. And I would go to visit her. And if I had to come into class, and let's say, for example, the class started at 5 o'clock, well, it's about 65 miles from where she lived to get downtown to Dayton. And if I left at uh, 4 o'clock, or even 3:30 would be safer, and I drove, and it's a 70-mile-an-hour stretch for a good bit of it, but then of course you got to get into downtown and park, and it takes a little bit to get into downtown. But if I left at 3:30 and I had a 5 o'clock class, that's reasonable. If I left at 3:50 and I have a 5 o'clock class and I got there, that's reasonable. If I left at even earlier than that, that would be potentially reasonable. So that if I left somewhere between 3 and 4, that gives me a really good chance of arriving at or maybe a little early for the class. So there's plenty of time for me to drive that, because if I can drive 70 miles an hour and it's 65 miles, I should be able to arrive there in about an hour, and that should be safe. So that 3 to 5 block range makes sense. Now, if on the other hand I told you I left Columbus at 4:30 and I got here at 5 o'clock in Dayton, that doesn't make any sense because there hasn't been enough time. Well, I've mentioned before I was a paramedic for years, and yes, I've driven Tahoe around, and I've gone ahead and I've gotten that thing up above the speed limit, and I can tell you at times I've managed to get that Tahoe up to nearly 100 miles an hour when I'm crossing from one side of town to the other, but I do that on a clear, dry day when there's really no traffic that's around. I wouldn't be driving that fast in and out of traffic on there, but I've had times where there's a perfectly straight stretch of clear, dry road and there's no traffic around, and I desperately need to get on the other side of town quickly, so I got the Tahoe up around 90 miles an hour on that. And as a result, I can make some good time. But even that, 4:30, you've been downtown, you don't park the car that quickly, so it doesn't make any sense that I could have left at 4:30 and still arrived down at Sinclair by 5 o'clock if I had 65 miles to go. So the only way that that could happen is if I said, oh, you know what, I actually left Columbus at 3 o'clock, and then I stopped off in Springfield, and they got a Hardee's there, and I like to get a roast beef sandwich over at Hardee's. So I stopped at Hardee's and got a roast beef sandwich, and I left Springfield at 4:30 and got here at 5 o'clock. That's where the 4:30 came in. Well, that's the halfway point. That sort of makes sense, because that's only about 15-20 miles from Springfield to get to downtown Dayton, and with parking and stuff, that makes sense. Yeah, okay, I can buy that, but I didn't have enough time to get all the way from Columbus. So as a result, there wasn't enough time for the signal to have traveled all the way from the sinus node. Even though I've got an upright P wave on all these beats, I do not have enough time with 1.5 block PR intervals here. I don't have enough time for that signal to have traveled all the way from the sinus node. And the QRSs are narrow, so I know this didn't start in the junction. So this is actually a junctional rhythm. And with the junctional rhythm here, I'm going to go ahead and turn this back on, and now you've got a kind of one over the top. But you can see in here, I have the same rules apply. It's not a fancy name. It's not a a short PR interval junctional rhythm. We don't have names for that. It's just another way that a junctional rhythm can present itself in here. So I choose my name, and with the rate being 50, that would be a junctional escape rhythm. Now, if the rate was 30, then it would be a junctional bradycardia. If the rate was 130, it would be junctional tach. If it was 90, it would be accelerated junctional. If it was 230, then it would be junctional tach at an SVT rate or a junctional SVT. So that's another way that we can have a junctional rhythm that presents itself. Now, let me clear this, and I'm going to show you the last primary way. Are there other ways? Yes, and you can look in the text and they'll talk about biphasic beats and things, and we'll talk about that as we get into oddball rhythms here in a few weeks. But for right now, I've got three primary ways I want you to understand how a junctional rhythm can present itself. So let me draw you an example of this, and let's kind of work through it as a group and decide. Just for fun, I'm going to try a different color just to change things up a little bit. So if I come across here, you're probably going to notice a little bit of a pattern here real quick. Always got to be that last one here. So I'll tell you what, we're going to clean that up a little bit. All right, so now if you look, I have narrow QRSs once again. I do have P waves, so I have atrial activity, but what's wrong with the P waves? They're not upright. And that's a problem, because if you remember we discussed sinus rules, I told you that the P waves had to be there. They didn't necessarily have to be round, and they didn't necessarily have to be symmetric. They usually are on a sinus rhythm, but they could be a little bit more pointy than they are round, and they could be a little bit asymmetric and still qualify as a sinus rhythm. But the one unquestioned rule on there is that for lead 2, when we're doing these rhythms here, you had to have an upright P wave. And if you look, all of these are upside down, or the fancy word for this is inverted. So I have an inverted P wave here. Inverted P waves indicate that this electrical energy is going in the opposite direction. So if I were to draw a picture of a heart here, on a normal beat, the energy is moving downward. So the positive electrode is down here on your left leg, the negative electrode is up here on your right arm, and that energy is in general moving downward toward the positive electrode. Now, if I instead, let me clear some of this out. All right, well, we'll get one back there. All right, if I start here in the middle at the AV junction and I go backwards, and I'm actually moving away from that positive electrode and moving toward the negative electrode, then I get this upside down P wave, or the fancy term is an inverted P wave. So if you see narrow, or actually even if you see wide, but for the most part, if you see a narrow QRS and you have inverted P waves, and the electrodes are set on correctly, that's an important part. Obviously, you get your right and left sides backwards and things are going to look weird. So you got to make sure you get the stickies in the right place. But if I see inverted P waves on here, that indicates that this energy started in the middle of the heart at the junction and worked opposite. It worked away from the positive electrode. The fancy terms for that piece are antegrade and retrograde electrical energy. Antegrade means that the energy is moving toward the positive. Retrograde means that it's moving away from the positive, or it's moving toward the negative electrode. So by looking at this, this is why it's important to have the electrodes in the right place and have everything else set up, and why the P wave should be upright. It means that the energy is primarily moving downward toward that AV junction, and also toward the tricuspid and bicuspid valves. If it's moving away from that, you still will get a push. You'll get blood that's pumping back out, so it'll work, and you'll overfill the ventricles, and the valves still work, so you still get good quality heartbeats and everything on here. But the electrical conduction, this beat actually started in the middle and worked away. So this is our third type of a junctional rhythm. So to give you the names on here, let me go ahead and we'll just switch that out in a different color here. If I have P waves, that's what I'm measuring. So junctional rhythms. So junctional rhythms, the P waves are either absent, as I showed in the first one. They are late, which means that PR interval, I'm going to just abbreviate that, PRI is less than 3 block. Or they're inverted. So absent, inverted, or late P waves. Any one of the three of those qualifies as a junctional rhythm. And then to determine what the name of the rhythm is, you use the process that we discussed. If the rate's 40 to 60, that's what you expect of the junction. It's called a junctional escape rhythm. If it's less than 40, it's junctional bradycardia. If it's in that 60 to 100 range, it's an accelerated junctional rhythm. And if it's in the 100 to 150 range, it's junctional tach. If it gets all the way up over 150, then it's SVT. It's still junctional tachycardia at that point. So the name really doesn't change overall, but it qualifies under SVT, which means that it's dangerous and fast enough that we want to try and manage that. We don't want to leave somebody that way. If you're getting chased by a wolf in the forest, like I said, when we talk about management, we'll discuss this a little bit. Or if you're running a treadmill, or if I have you run up a flight of stairs real quick to get your appointment on time, and I check your heart rate and your heart rate's 160, I'm going to give you a few minutes to calm down first. But if you're sitting in class trying to stay awake through a lecture, or if you're sitting in a waiting room, or if you're sleeping, or if you're laying down in a hospital bed, or if you're just sitting in the doc's office and you've been there for a while and your heart rate's up over 150, there's something that probably needs a little bit of management. Essentially, we've covered a lot of ground here, so that's going to bring this to a close, but the junctional rhythms all rely on what's happening with the P waves. Now, if you notice on here, in these cases, we typically have narrow QRSs. So the QRS is going to be narrow. We have junctional rhythms, though. We look at the P waves. If the P waves are absent, that qualifies. If they're late, meaning that the PR interval is less than 3 blocks consistently, and if they're inverted. As we practice and get better and better at looking at these rhythms, I will explain this and you'll get a chance to kind of see how these work. The PR intervals, if it's like 2.9 blocks, if you would round it and say, yeah, that's 3 blocks, just count it as 3 blocks. If you look at the PR intervals, if you remember a couple ways we can measure PR intervals, it's 120 to 200 milliseconds. So if it's 119, technically it's a junctional rhythm. But arguably that 119 to 121 is so negligible it doesn't really make that big of a difference. If visually it looks like it's 3 blocks, it's fine. And we'll also talk a little bit as the rhythms get faster and faster, there's a bit more tolerance. So if you see one that's even 2.5 block intervals, that's probably still an atrial tachycardia there. But if it's getting down to 2 blocks or less than 2 blocks, 2 small blocks for the PR intervals, that's a pretty strong indication that you've got a junctional rhythm. And the best way to determine that for sure is to go ahead and slow the rate down. Because if you've got a slow heart rate, if I have a rate like this, a rate of about 50 beats per minute, and I have a PR interval that's 2 blocks, that's a junctional rhythm. That means that this heart rate is not, or this heartbeat is not being generated all the way up the sinus node. It's being generated at the junction, whether or not it's inverted. So you can have short PR intervals and have an inverted P wave as well. So, and that still would be a junctional rhythm. But absent, inverted, or late, absent, late, or inverted P waves here with the narrow QRS is classified as a junctional rhythm, and then you use the rate in order to determine the final name of the rhythm. If you have questions, as I've always said, please feel free to email me and let me know. I'll give you a chance to practice some of these. I strongly recommend that you read the chapter on junctional rhythms and take a look at the sample rhythms that are there, and we'll get you a chance in class to practice a few of them, and we'll be quizzing and testing on them.